So now that we've run our first few MapReduce jobs, let's talk about the different ways that you can run MapReduce jobs. In production, you're going to configure your job conf options. You're going to set things like timeout values and paths for the output, paths for the input for the data. For us as developers, we won't often use those complexities. Rather, we'll work from our IDE or our coding environment, and we'll usually either just create a jar file in our coding environment and then run it from a command line, or we could actually use unit testing framework and just stay within our coding environment. But I did want to show how a MapReduce job is actually run in production because I think it's important to understand the destination when you're writing that code. Now, I usually run my MapReduce jobs in a GUI utility rather than from the terminal because it's just a little simpler and has richer output. So I showed Cloudera Hue. If you use a different distribution, like, for example, Microsoft Azure HD Insight, there's a rich console you can use. Most of the commercial vendors have a lot of instrumentation and monitoring around job execution because that's a core part of actually running Hadoop in a production environment. Just as a reminder, from the command line, you would issue the Hadoop jar command, and then you put the file name for the jar and the input and the output locations. Now, in terms of job execution optimization, a common paradigm is called speculative execution. And what that will do will kill long-running jobs based on configurable parameters that you set, either in the source code or more commonly in the execution environment. In, for example, Cloudera Hue, you can specify the overhead it takes to run a job, the number of mappers, the number of reducers, so on and so forth, so that a job can be automatically killed if those values are exceeded. This is a common situation in production code, so I wanted to include it here. Now, we're going to come back to the world of being developers, and we're going to dig into methods to write MapReduce jobs. We saw an example of the Java code for the MapReduce 1 API, and we're actually going to write from scratch a MapReduce job using the more common MapReduce 2 code coming up here shortly. The standard way to write a MapReduce job is in Java, and I usually use Eclipse, although you could use something like Vim if you wanted to. Some people prefer to write MapReduce jobs using the streaming paradigm, where they start with a Java scaffolding, and then they use the standard in, standard out methodology, which is like a piping, and then they can write the logic of their mapper or their reducer in their language of choice. And I see things like Python or C# or even JavaScript. Pipes is another method to write a MapReduce job, and the most common language that's used with that is C++. Now, in addition to traditional programming languages, there are a whole wealth of abstraction libraries that I'll be covering in this course that a lot of people prefer to use because they're more fluent in these particular languages. There are things like Hive, which uses a ANSI SQL-like syntax that allows you to write in a database query-like language, and then it will generate the lower-level MapReduce. Pig, which is a batch language that's used in extract, transform, and load processes where you're actually doing data cleansing. It's really common that people will prefer to work in a higher-level language. But I do think it is important that you understand at least something about the internals of MapReduce because these languages do generate MapReduce jobs. In fact, this just gives you an idea of the wealth of languages and libraries I see around the Hadoop ecosystem. So one of the tips that I would give you is you want to figure out at what level of abstraction you and your team is comfortable working with the MapReduce paradigm. If you have a group of OOP programmers at your disposal, then you may want to work with Java. Even if they're C# programmers, it's pretty easy translation. If, on the other hand, you're surrounded by mostly business analysts and you really don't have too many programmers on staff, you might want to focus on higher-level languages like Hive or Pig or some of the other ones. This is a really important architectural consideration when you're implementing Hadoop in a production situation because you really have to have the appropriate level of understanding of the language so that you can implement the data processing paradigm in a way that's going to allow you to get value out of all that data you're storing in HDFS.